Welcome. Today we'll analyze the trigonometric function y equals -3 sine of 2x plus pi over 2. We'll identify its amplitude, period, and phase shift, and understand how these features affect the graph. Let's start by comparing this to the standard form of a sine function. The standard form is y equals a sine of bx plus c, where a affects the amplitude, b affects the period, and c affects the phase shift. Let's visualize how each of these parameters affects the graph. We'll start with a basic sine function and modify it step by step. First, let's look at the amplitude. In our function, a equals -3, the absolute value of a, which is 3, determines how far the function stretches vertically from the midline. The negative sign causes the function to be reflected across the x-axis. Next, let's examine the period. In our function, b equals 2, the period is calculated as 2 pi divided by b. So, our period is 2 pi divided by 2, which equals pi. This means the function completes one full cycle every pi units, making it twice as frequent as the basic sine function. Finally, let's analyze the phase shift. In our function, c equals pi over 2. The phase shift is calculated as -c divided by b. So our phase shift is -pi over 2 divided by 2, which equals -pi over 4. This means the function is shifted pi over 4 units to the left. So to summarize, our function has an amplitude of 3 with a reflection, a period of pi, and a phase shift of -pi over 4 units. These three parameters completely determine the shape and position of our trigonometric function.